Hello, this is Dalal Abed from the University of Michigan Dearborn. I'm a student part of the graduate computer engineering program, and for this semester, I'm taking the class Cloud Computing. As a topic for the final presentation, I picked connectivity as a service for vehicles to be my topic. Basically, I want to highlight how important connectivity has been for automobiles and how the cloud computing and cloud systems are contributing to this new connectivity push and need for vehicles to be more connected. Connectivity these days is a very attractive word. Most of the consumer products, service providers would like to offer the most connected thing, the most connected product, whether it's the most connected phone, the most connected network, or the most connected Internet of Things device. And the automotive industry now has a big push to also provide the most connected vehicle because that's the product of the automotive industry. And we're going to explore how cloud computing has a big part and role in providing more connectivity to the vehicles. Even though in this class we've been taking a deep dive into the cloud computing and what it means, I wanted to explore other definitions from the internet. So Microsoft Azure defines cloud computing as the delivery of different computing services like databases, servers, storage, networking, software, analytics, and more all over the internet, which ultimately makes up what we call the cloud. So buzzwords are internet, network, remote, and servers. Connected cars is the given name for vehicles that have connectivity. And in the recent years, you have seen vehicles having some sort of connectivity. And that all because these vehicles have what's called a telematics head unit. And I'm going to talk about it later in this presentation, but it basically adds cellular connectivity to the car system and ultimately connects the vehicle to the internet, and then it could connect to multiple things. Some of the features that this connectivity has been enabling the vehicle to have is having phone calls through the vehicle, the possibility of remotely controlling the vehicle, some of the features of the vehicle, and also the update of infotainment applications. Now I'm going to highlight some reasons of why we need connected vehicles, or why do people need connected vehicles. And one of the first important reason is cost savings. And these cost savings come from reducing some of the vehicle hardware required, because now you're relying on cloud servers and cloud-based storage and also cloud-based processing to limit or lower the number of components, or even physically make the components in the vehicle smaller because you don't need to have the same storage. Another reason is faster service and maintenance. This is going to be a huge game changer once the vehicles are very connected. Basically, you're going to be able to have remote diagnostics of the vehicle, identify if your vehicle has any issues, and there's also a possibility that if the diagnostics found an issue, that you actually get a push over the air of an update to fix this issue that was found. You will get remote notifications of health status updates of the vehicle, and this vision will ultimately lower the number of visits to the workshop. So you're definitely going to see less dealership service shops around, and you will see vehicles going there less because of this remote maintenance that's going to happen, and also remote diagnostics. You might still want to go there for some hardware issues, if existing, but a lot of it will happen over the air. Another important reason of why we want to have connected vehicles is over the air updates. So there will be the ability to have major updates to the vehicle over the air. That's because you're gonna have these software or firmware updates saved on the cloud and easily be pushed over to the vehicle. So some of these features, of course, include software over the air update and firmware. Some of them highlight like powertrain updates, which is actually currently happening with Tesla vehicles. So Tesla allows powertrain updates to be pushed to the vehicle over the air, and some examples to that is pushing improvements to the acceleration time, reduced restriction to allow for increase in top speeds, and location-based air suspension, which has history of potholes locations. Another over-the-air update is map updates, which will increase the performance of navigation systems, because if the navigation system has the most updated maps, it will be able to make smarter and better decisions. Another big one is autonomous driving features. Uh, Tesla is doing this as well. It's basically they send new features to the vehicle for autopilot, which is the feature for their autonomous driving, and they do that all over the air. So they will have to push the update from the cloud server into the vehicle, and usually that happens when the vehicle is connected to the Wi-Fi network and therefore connected to the internet and can have access to the cloud. Remote vehicle control is another reason why we want to have connected vehicles. This is a very nice and fun feature, and I personally like it because I have some of it on my current vehicle that I drive, which is the Dodge Charger. Basically, if you look at the right side image of a Tesla vehicle, this is an application that Tesla have developed, and through this application, you can basically control the climate of the vehicle. You can check on the charging status. You can set the temperature inside. You can locate the vehicle, and you can maybe start lock and unlock and start the vehicle, and this happens through the process that's highlighted on the left side, which is basically the phone app or the app on the browser will send a command to the cloud server saying, hey, I want to access the vehicle because I want to send a command to it, and then the cloud will connect to the network, and the cellular network will send an SMS to the vehicle to wake up the telematics unit, and then it will be able to access this information, and also we'll be able to change this information and get live status update. How can the vehicle be connected to the internet? Two ways. The first one is the telematics control unit, which I highlighted earlier through the slides, and it's basically a physical part installed in the vehicle to enable it to have cellular connection, and via the cellular connection it can access the internet and then the cloud, and this is through GSM connection or LTE connections, and to simplify, these refer to speeds of data transfer. And additionally, it's the connecting to the Wi-Fi, and this does not mean having a hotspot in the vehicle. This is actually having a Wi-Fi antenna in the vehicle so it can connect to a Wi-Fi connection, whether it's at your home or at your office, and this to enable the vehicle to have direct connection to the internet, a stable connection, and probably a higher data transfer connection. And these two methods are used for two different features, and we can highlight some of the differences in the connections. Let's highlight some of the in-vehicle cloud-based apps and features that the vehicle could have. The first one is artificial intelligence, and one example of that is autonomous driving. Autonomous driving is considered an artificial intelligence app because it requires massive data analytics, training models, and simulations. And the cloud system is definitely required to perform all these activities because the vehicle will not be able to handle all this processing and data storage. Another example and feature is user profiles, and this is basically creating profiles for drivers and passengers inside the vehicles to enable them to personalize features or settings like the seat position, the climate preference, the media preference. And these user profiles will be created via the vehicle environment, but ultimately all saved on the cloud. And we'll be continuously updating through the journey of these drivers and passengers because these settings will definitely be changing all the time. Seamless vehicle entry is another feature that I'm really interested in, which could be using your phone as a key to the vehicle or face as a key to the vehicle via facial recognition. And in the next slide, I will explain a little bit of how we can achieve that using a cloud server. This is how the facial recognition process will happen and to be used as face as a key. Basically, when the user approaches the vehicle, there will be a button or a method that they will start this process. So the vehicle will send a request to the cloud via the network to start the facial recognition algorithm. And once the cloud receives that, of course, via an IP address, and then there will be a port address to this facial recognition algorithm, the algorithm will send a request back that it needs a live feed, a live video feed from the vehicle via an external camera that is installed already on the vehicle. Once the vehicle receives this request, it will start streaming the live video via the network into the cloud. And once that data reaches the cloud, then the actual facial recognition algorithm will start processing, basically authenticating that the face that it's receiving through the network is the same face that it has tied to this user. And then the authentication result will be processed and sent back to the vehicle through the cellular network. And if the authentication is approved, then the vehicle will open. If not, then it will not open. You can see that there might be a security and safety, mostly security risk in this information and data being wirelessly shared, and a lot of users might not feel comfortable having their faces being on the cloud. So these security risks have to be seriously addressed and need high security methods and encryption methods so that vehicle owners will feel secure and safe using such a vehicle entry method. Other features and applications include vehicle to everything communication. And this could be vehicle to network, vehicle to other vehicles, vehicle to infrastructure, and vehicle to pedestrian communication. And this will heavily rely on the vehicle having connectivity to the cloud because all of the information that these other networks or vehicles or infrastructure has will be ultimately stored on a cloud server or cloud system. So the vehicle definitely needs this connectivity because it will have access to massive information and it will enable the vehicle to make decisions, driving decisions, especially when we get more involved in autonomous driving. Other features include infotainment apps and Internet of Things devices, basically the devices at your house. The IoT devices can also be connected to the vehicle all via the internet. Another feature is in-vehicle dash cameras. So dash cameras have been an after-the-market device that people add to their vehicles. But now we see a trend that these cameras will be part of the vehicle. So these cameras will be installed in the vehicle, and basically the recording will happen all the time, but the vehicle will not handle or prepare storage to save all of this data. So when the vehicle is parked and connected to a Wi-Fi connection, the vehicle will take all these dash camera recording and dump it in a cloud server, and then allow the owner to have access to this data and recordings whenever they need. I wanted to highlight some of the cloud service options that automotives have to rely on in providing a higher connectivity vehicles. Some of them are the Amazon Web Services, which is a popular cloud service that OEMs should consider as a cloud for all this connectivity. Another one is Microsoft Azure, which is also making a difference in the connected vehicle experience. They offer services like telematics and predictive services, productivity and digital life, and advanced navigation. IBM also has a cloud computing solution which is called Connected Vehicle Insight, and it's basically a software that acquires data from sensors and systems to improve the vehicle experience. It's a cloud service to manage and analyze big data from multiple connected vehicles. Connectivity as a service. This is expected to be the big new thing as a service in the cloud world, in the cloud computing world. This is what a lot of people are calling this need of big connectivity for vehicles. Whether it's even mobile devices can have connectivity as a service, but you can imagine that the vehicle is also kind of like a mobile device that has wheels. It will ultimately become this device that's just running around. It's a service of providing super connectivity, and this is achievable by having connection to the cellular and the cloud system, and this will provide users fast, continuous connectivity wherever they go. It's envisioned that connectivity as a service is the new model for cloud computing, and this will allow developers to personalize and customize connectivity for the devices. As a conclusion, I wanted to highlight that cloud computing is the key factor in changing the automotive industry and the driving experience. The next few years are very critical in changing that driving experience. With the usage of cloud services, vehicles will be more connected than ever. The vehicle will be connected to infrastructures, other vehicles, to the cellular network, to cloud system, and it will have high visibility to massive data. And the cloud is a key factor in enhancing the development of autonomous driving, because the cloud will host important data from sensors that the vehicles will have to access when driving autonomously. A lot of the autonomous processing could take place on the cloud. Thank you for watching this presentation, and I hope I quickly highlighted how important the cloud computing world is for automobiles and how critical it is to change the future of driving and transportation.